Electricity in magnetism concept and equations. From physical observation to electromagnetic field equations, that is Maxwell equations. So in this lecture we are trying to understand how the electricity and magnetism works. So we will start with the basic concept. The historical motivation of the electromagnetisms are: electric charge create electric field force. What that mean? That mean that when we have a charge, let's say positive charge, so it will create a field around it. And if we have a negative charge, that line will converge to that negative charge. So outside these charges, outside here, we have electric field lines or electric field force. Moving charges create magnetic field. If charges charging or moving, they create magnetic field. Let's say we have a line and let's say positive charge moving in it in this direction. So if these charges are moving in the line, so there will be a magnetic field around this line. It creates a magnetic field around this line. So moving charges create magnetic effect, mean magnetic field. So if a charge is static, it has an electric field around it, but if it start moving, so the electric field remain the same, but it create also an a magnetic field. Experiment by Faraday, Ampere and Gauss revealed electric and magnetic field relationship. So these scholar says that there should be some connection between the magnetic and electric field, because you see when electric charge moves, it creates magnetic field. So clearly we see some connection in between. What Maxwell did, Maxwell actually unified the concept of Faraday, Ampere and Gauss. They gave a unified theory of electromagnetism and also light. So there are 4 Maxwell equations which unify the electromagnetism, and we will discuss in detail in some video the derivation of those equations. Here in this video we will only see them and discuss a little bit, but in next time we will derive them. So Maxwell is the man who unify the electricity and magnetism in one theory which is called electromagnetic theory. Okay, what is Gauss law? This is the Gauss law in the 4th case. So what is the concept behind this law? electric field lines originate from positive charges and terminate on negative charges. We discussed in the first slide that if we have a positive charge and a negative charge, line will start here and it will converge to the negative charge. The electric flux through a closed surface measure in closed charges. So if we have a closed surface somewhere, let's say from this system out we have some closed surface. Oh no, this will enter the negative charge. But if I take closed surface over here, that will tell us about how many charge is enclosed in this surface. But in this time, in this case, there is no charge inside, so zero charge is there. But if someone draw a closed surface or closed path in electric field, and so that what they will get either zero or something. So if it is something, then this must be this one, the charge density over epsilon naught. The epsilon naught is permittivity of the free space. Its value is given over here. So if charge is inside, so that charge what will affect this much. This is the divergence of the electric field. So the divergence of the electric field is this value, charge density over epsilon naught. So if there is charge inside the closed surface, that will be this value, sigma over epsilon naught. But if the divergence is zero, let's say divergence of E is zero, then that mean that the closed surface has no charge. You have a closed surface with the divergence is zero, that have no charge density inside. So that means outside the charges, if we draw a closed surface or closed path, we will have the divergence of E to be zero, because outside the source the divergence is zero. That means if here is the charge, here is the charge, let's say plus charge, so it will have a field originate from it on all sides, but the line enter the closed surface and leave the closed surface in the same number. If 10 line enter inside the closed surface, 10 line will leave the closed surface, so the net divergence of the field is zero. So outside the source, a closed surface or closed path have zero divergence for E. But if it has some value, that value must be this, that is the Gauss divergence law. It is this value, rho over epsilon naught. Rho is the charge density, so it will tell that how much charge is inside the closed surface. But if the closed surface has zero density or zero charge, then the divergence will be zero, because line entering and leaving that surface are equal and they cancel each other. This is the Gauss divergence concept of the electric field. So how you can measure the charge density. This will give you the charge density in certain region. If you take closed surface in certain region and want to calculate how much charge enclose that surface, this is the formula. This is the Gauss divergence formula. This will give you the answer. Gauss law of magnetism. It is also Gauss law of divergence, but it is the previous one was for the electric field and this is for the magnetic field. So what Gauss observations are about the magnetic field? Magnetic monopole have never been observed. Mean, if you have magnetic field, that will be due to magnet of south and north pole. So you cannot separate the south and north. The first thing, the first observation says that there you cannot find a separate north pole or south pole. So magnetic monopole never have been observed. So you cannot separate them. If you cut them in half, you will get a small one, but that will also have south and north pole. And keep on division, you will reach to a very small magnet, but that will have the two poles, south and north. So you cannot be succeeded in this experiment to find a monopole, either south or north. Magnetic field line always form closed loop. So when you have, so the line start from the south and enter into the north. So all lines originating from south and goes into the north, and it is a loop, a closed loop. So all the line will start here and will enter ultimately into the north, and it will form a closed loop. So magnetic field lines always have closed loops. Net magnetic flux through a closed surface is 0. That is given in the fourth option. Differential form of this, the divergence of the magnetic field is 0 always. So that is the concept of the first, that monopole does not exist. This must be south pole and north pole, and line will start from the south and end at the north. When you take a closed path anywhere in this in the magnetic field, you will always these will end over here. So anywhere you take the closed path, closed surface, anywhere line will enter and leave in same number. So the divergence always be 0 for the magnetic field. If it is a magnetic field, then there the divergence always 0, because closed loop, closed path or closed surfaces have divergence 0, mean the lines entering in that closed region must be equal to the line leaving that region. So they will cancel each other, and the net divergence of the magnetic field should be 0. And this is the consequence of the first one, that there is no magnetic monopole. Faraday law of induction. Changing magnetic field induce electric field. Foundation of electric generator and transformer is this induction, and in mathematical form of this is this. What this says that, let's say you have a closed coil. This is a closed coil, and you have a magnet. Let's say magnet. So let's say here is the south and here is the north, so that the line originating from the south and passing through the coil. Okay, so some will move this way. Okay, now if we move back and forth this magnet, if we move back and forth this magnet in certain region, back and forth, so the magnetic line passing through this coil will change in number. It increase if you move toward the coil, and if it decrease if you go away from the coil. So the magnetic line passing through this coil changing in time, and that will produce current in this coil. So that will push electron in certain direction. So if you move back and forth the magnetic line changes in passing through this closed loop, and that will cause to move the electron in this coil. That is called Faraday law of induction. And vice versa, if you move back and forth the coil, that will also work. So either we have to move the coil, away and near to the magnet, either we have to move this coil back and forth or magnet back and forth, so that the line passing through the coil changing in time, that will induce electric current inside this coil. That is the basic principle of the generator. So you see, this is mathematically written over here. The curl of E is changing magnetic field in time. So changing magnetic field in time, you have the rotation of the electric charges, that mean curl of E. Curl of E change magnetic field in time. Okay, so this is the basic principle of the generator. Ampere law. Current generate magnetic field. Now electric field generate magnetic field, opposite of the previous one. That is, magnetic field, changing magnetic field create electric. Now electric current generate magnetic field. If we have some wire and current electricity passing through it in certain direction, magnetic field form around it. So that is, the electric current generate magnetic field. So the electric current generate magnetic field. Mean motion of the charges generate magnetic field. Motion of the magnet generate electricity. Motion of the magnet generate electricity. Motion of the charges generate magnetic field. So if there is charge in motions, there should be magnetic field in that region. If the charging is moving, so they create the magnetic field. But if the magnet is moving, that create electricity if there is a coil in that region. Okay, Maxwell added displacement current. This is a very important concept, that the displacement current, because all the electronics and wireless appliances are working on the displacement current. We have to do a separate video on this displacement current. But before Maxwell, this displacement current concept was not known. So Maxwell added displacement current in time varying electric field. What is time varying electric field? That means when you have a capacitor and you charging the capacitor, let do something for it. You have a capacitor, plus and minus, let plus and minus, and you are charging it. Okay, you connect this with a charger and you are charging it. So what happening? Positive charge increases or negative charge increases, and that changes the electric field inside this region. This means the electric field strength increases when you charging the capacitor, and when you discharging the capacitor, the electric field decreasing in this region between the plate of the capacitor. So this changing in the electric field, this changing the electric field is in fact the displacement current. That is called the displacement. Maxwell called it the displacement current. There is no wire between these two plates, but the electric field is changing due to the charging of the capacitor. That changing the electric field is called the displacement current, named by the Maxwell, the scientist Maxwell, and that is this term. You see, if you charging a capacitor, the electric field is changing in time. So that is the partial E partial T term. So when you charging the capacitor, so the change occur in the electric field between the plate of the capacitor in time, and this is the displacement current term added by Maxwell in the Maxwell equation. Before Maxwell, only this term was there, that electric magnetic when the current is flowing in wire, when the current is flowing in some wire, it create magnetic field around the wire. So if you have a wire, and current is passing through it, electric field is swirling around it, and that is the curl of B. So when current is flowing, it creates the magnetic field around the wire, around the region in which the current is flowing. And this is the displacement current. That concepts come from the capacitor. Now there is no charge moving here, no charge moving over here, only the electric field is changing, and that electric field is changing is written in this term. so that electric field change also produce magnetic field over here. So the magnetic field around the wire is not only around the wire, but it also in between the plate of the capacitor there is magnetic field swirling around the lines, because the lines number of line increase decrease due to the charging and discharging of capacitor. So the displacement current is due to the field changing. So when the field is changing, it also create the magnetic fields there, and when the current is flowing in the wire, that also create the magnetic field. So current here, the current is flowing, so there is a magnetic field everywhere around this wire. But when it come here, then after this there is no current. But what happening here? Is there any magnetic field here? Yes, that is due to the change in the electric field between the plates. So when current is flowing in this wire, that is the wires of the charger, and electric field is around that wires. But when it come to the capacitor, plate of the capacitor, in between the plate of the capacitor there is no current, but there the magnetic field there is produced by changing the electric field. The electric field is changing due to the charging of the capacitor, charge increase decrease on the capacitor. So this displacement current is very important, and you see mobiles and wireless devices work on this this term, because there is a distance between the booster and the mobile, and you receive the signal and voices and sound voices of the caller. That is due to the displacement current. Okay, this mu naught, we discussed the epsilon naught, that is permittivity of the free space, and mu naught is the permeability of this free space. It is called the magnetic constant, while the epsilon naught is called the electric constant. So this is the magnetic constant and this is the electric constant, and this constant is related to the speed of light. And you see here is this -7 is in the power of 10. Here is the power of 10. Okay, so this is 4 5 10 power -7 Henry per meter. That is the value of the mu naught, the permeability of free space. Okay, these are the Maxwell Field equation. This is the divergence of E is rho over epsilon naught. The divergence of B is always 0. The divergence of E is 0 in outside the source. Okay, so the divergence of E is 0 outside the source. Okay, so I'm writing it over here, that the divergence outside the source. Okay, outside the source, the divergence there be 0. I explain it, but let's see it again. Is a plus source, it create a field, but if you take a closed path over here, the divergence from this closed path should be 0, and that is written over here. But if you close, but if it is not 0, it should be this value by Gauss, that is rho over epsilon naught, where rho is the charge density enclosed in the closed surface or closed path. but the divergence of the magnetic field is always zeros, and that is why, because the magnetic field has no monopole. There is monopole for the electric field, plus charge or minus charge, they are monopole, but we cannot find separately south pole or north pole for the magnetic field. That is why the divergence of the magnetic field is always zero for any closed path, whether you enclose the source in the closed surface or closed path, or some part of the source in the closed surface and path, you will get always the divergence is zero. We discussed this equation that changing the magnetic field, this is the rule of the generator. Changing the magnetic field in time will create electric current. And the last one also is, we discussed that current flowing in a wire create a magnetic field around the wire, swirling around the wire, and the changing electric field inside the plate of the capacitor also create the magnetic field. And this term is very important term. All the wireless devices work on this term, and this is added by the Maxwell in these equations. So the first two are the Gauss divergence equations. The third one is the Faraday equation, and the fourth one is the Ampere equation. But the Ampere equation, this term was absent, it was added by the Maxwell, is displacement current term. Okay, so we have to make a video on combined Maxwell equation predict electromagnetic wave. So we will do it in some video that combine all the Maxwell equation, give us wave equation. Wave equation. Okay, electric and magnetic fields sustain each other. What that mean? If there is electric current, that generate magnetic field, but magnetic field itself create the electric current. You see it that when the magnetic field changing in certain region, there should be electric current flowing in that region if we have a coil there. But when the charge is moving in the coil, that create the magnetic field. So they both sustain each other. Okay, light speed is given by this constant, and we will calculate it in other time. This is, and from this the Maxwell says that the light is in fact the electromagnetic spectrum, and light is an electromagnetic wave. Because of this, when Maxwell calculated this value, it is exactly equal to the speed of light, and they says that the speed of light, that mean light moves with this speed, that must be electromagnetic wave. So light after that declare that it is electromagnetic wave. Okay, unified electricity, magnetism and optics. This Maxwell work. Introduce field theory as a fundamental description of nature. Laid the foundation for relativity, and so this is very important, and we will do it in some video. That in fact relativity start from the wave equations invariance, we will discuss it in some video that in Galilean transformation. In Galilean transformation, the wave equation is not invariant. So we need another transformation under which the wave equation remain invariant, and that transformation is the Lorentz transformation. So in fact, the foundation of relativity start from the Maxwell theory, Maxwell wave equation. Okay, so we will do these two in detail in other videos. Thank you. Any question, discussion? If this video is helpful, then like it, subscribe, and comments for improvements. Your comments will help us correcting things